So similarly, if you go for the next molecule, that is oxygen and nitrogen, you take O2 or O2 molecule and you pick up one oxygen here, atomic number is 8, helium of, that is 2s2, 2px2, 2py1 and 2pz1. You know very well that oxygen contains 6 valence electrons. These are the these are valence electron orbitals of oxygen. If you go for the electronic structure of oxygen also, if you take, there are two shells in the oxygen atom, wherein which the first shell has 2 electrons and the second shell has 6 electrons. These 6 electrons are shown in the form of, that is 2px2, 2py1 and 2pz1, and because the 2p subshell or the sublevel is degenerate in nature, the 2px orbital and 2py orbital and 2pz orbital, they are definitely they are degenerate and they have double shaped structure. But what is interesting here is you find that 2py atomic orbital and 2pz atomic orbital of the oxygen, they have unpaired electrons. You can see one unpaired electron in 2py orbital and one unpaired electron in the 2pz atomic orbital. So you take 2 oxygens, because it's an oxygen molecule, you need to take 2 oxygen atoms. First oxygen atom, I'll just take it like this. This is py and pz, so I'll just take it, this is py and this is pz. This is py, pz, py we have, okay, I'll show it with the electrons instead of density. I'll just show it with the electrons. So here we have one electron and here we have one electron. This is for first oxygen. Go for second oxygen. Again, you can take the same arrangement for the second oxygen also. First py atomic orbital, pz atomic orbital with again one more unpaired electron. So the overlapping takes place here. This is before overlapping, py, and this is pz. Again, this is for second oxygen. This is before overlapping, during overlapping or after overlapping. After overlap, you find that 2 clouds are formed here. One is, this is sigma cloud, and this is pi cloud, and this is sigma cloud. So thereby we can easily predict, saying that between 2 oxygen atoms, first cloud is, first bond formation is because of the sigma bond formation taking place between the py atomic orbital of the first oxygen and py atomic orbital of the second oxygen. They are overlapping along the internuclear axis, end on end overlapping, and this is sidewise overlap. Sidewise overlap results in the formation of the pi cloud, and the end on end overlapping of the atomic orbitals results in the sigma cloud in oxygen molecule. That is why the oxygen molecule contains one sigma bond and one pi bond. One is sigma and the other one is pi bond. Hence the overlapping in the case of O2 molecule is quite convinced, and it is justified to say that the oxygen molecule is having a double bond between the 2 oxygen atoms. So here the last molecule, that is nitrogen molecule also, let us prove that in nitrogen molecule also P2P overlapping is taking place. So if you go for P2P overlapping, here if you take nitrogen molecule, N2 molecule, if you take nitrogen, atomic number is 7, so write the nearest noble gas configuration. helium of 2s1, helium of 2s2, 2px1, 2py1 atomic orbital, 2pz1 atomic orbital. What you are noticing is the atomic number of nitrogen is 7, so the total number of electrons present in the nitrogen are 7 electrons. So helium contains 2 electrons, 2s orbital contains 2 electrons, and 2px1, 2py1 and 2pz1, total 7 electrons. But interestingly, these are the valence electrons of nitrogen. These are the valence electron orbitals, and in these valence electron orbitals, only those orbitals which have unpaired electrons in them. Here you find for 2px orbital we have unpaired electron, 2py atomic orbital we have unpaired electron, and 2pz atomic orbital also we have unpaired electron. So take those three 2p, x, 2py and 2pz atomic orbitals which are having unpaired electron between two nitrogen atoms. These three atomic orbitals, p atomic orbitals, which are degenerate belonging to the same sublevel, they have opposite spins between two nitrogen atoms, and this opposite spin electron shares equally between the two nitrogen atoms, and the overlapping takes place. When the overlapping is taking place, you find a pair of atomic orbitals, they try to overlap end on end, resulting in the formation of sigma bond. Rest of the two pairs of atomic orbitals, they try to overlap sidewise or lateral overlap, and that results in the formation of two pi bond or pi electron clouds. Let us see what is happening by drawing a orbital diagram here. So you take first nitrogen, here you have, this is 2px, this is 2py atomic orbital, and this is 2pz atomic orbital, 2px, 2py, 2pz atomic orbital. This is simply, I'll write it as px, py, this is py, and this is pz of first nitrogen. Go for the second nitrogen. If you take second nitrogen also, you have again one px atomic orbital with a cross. Apply the Lewis electron dot structure method. So this is px, this is py with an unpaired electron, this is py, and this is, next one is pz of second nitrogen. So it is very clearly understood that the px of the px atomic orbital of first nitrogen and the px atomic orbital of the second nitrogen, they overlap along the internuclear axis. They overlap along the internuclear axis, px and px, that will result in the formation of sigma bond. So this is after overlap. After overlap, you find one sigma cloud like this between px and px. You find one sigma cloud, px to px. You can just show it here like this, px, one pi cloud like this, another pi cloud, this is one pi cloud, is two pi clouds are formed. So therefore we can come to one conclusion saying that here sigma bond is formed because of px to px orbital overlap, and one pi bond is formed because of pz to pz overlap. Another pi bond is formed because of py to py atomic orbital. So these three bonds in nitrogen molecule finally results in the formation of triple bond, where in which the middle one is sigma bond, the above one is pi bond, and the below one is again pi bond, thus resulting in the formation of a triple bonded molecule. So therefore it is proved that the nitrogen molecule contains one sigma bond and two pi bonds after the overlapping, and it is a triple bonded molecule.